Good morning, YouTubers. Welcome to BMW Programming and Encoding channel on YouTube. Today we're working on BMW G12. This car last week, we tried to program the body movement controller. I managed to write the VIN number to it and the I-step shipment. And we only go thus far. We needed the latest PSDZ data version for this car, but the BDC comes with the gateway in programming aboard, but the BDC body does not. You know what I mean? So the BDC body is communicating, but the central gateway is communicating as well because the both of them is built into one unit. But the gateway was not really programmed by the dealership. Somebody screwed it up there when they were probably writing the VIN, and are they deliberately put it into programming abort, so you have problems with it. But I've programmed BDC before that was in programming abort, where the gateways was in programming abort and was restored, and I use ESYS to restore it. So we're gonna try to use this one to do shit. Alright, currently we are running BMW ISTA AOS from the BMW TIS portal for North America. This car currently is in Doral, Florida, and I'm doing this car from my home in North Miami Gardens. Okay, so bloom. Here we go.
FlexRay is a high-speed, fault-tolerant communication bus designed specifically for demanding automotive applications. BMW was an early adopter, implementing it widely to manage the huge amounts of data required for complex, real-time control systems like the Integrated Chassis Management (ICM) and advanced safety features. Unlike the traditional CAN bus, FlexRay offers significantly higher bandwidth, up to 10 megabits per second, and, most importantly, deterministic communication. This means data is guaranteed to arrive within a specific, predictable time frame, which is absolutely crucial for systems requiring split-second synchronization and reliability. To begin our deep dive, we have a few paths we can take: architecture and protocol. We can dive into the technical details, like the communication cycle, frame structure, and how FlexRay achieves its time determinism and fault tolerance. FlexRay versus CAN. We can compare FlexRay's capabilities to the more common controller area network (CAN) bus to understand the limitations of CAN and why a new protocol was necessary for modern vehicles. Real-world BMW applications. We can look at the specific BMW systems that use FlexRay and why they need its speed and reliability, such as active steering and suspension components. Which of these areas seems most interesting to start with? BMW's most achieves its speed and predictability through a concept called the communication cycle. This cycle repeats continuously and is divided into two main parts for data transfer: static segment, TDMA. This segment is the foundation of FlexRay's deterministic nature. It uses time division multiple access, TDMA, meaning the total time is divided into fixed, guaranteed time slots. Specific electronic control units, ECUs, are assigned their own slot. Since an ECU only transmits during its assigned time, there are no collisions, and the data transmission time is completely predictable. This is critical for active safety and chassis control systems. Dynamic segment, mini-slotting. This segment provides flexibility for data that isn't time critical, like diagnostic information. To start our deep dive into the protocol, how does this concept of a dedicated, pre-assigned static segment contrast with the way data is typically transmitted on a traditional CAN bus, where multiple ECUs can try to talk at the same time? The contrast between FlexRay's static segment and the CAN bus is fundamental to understanding why BMW adopted FlexRay. The key difference lies in how they handle simultaneous transmission requests, CAN bus, arbitration. The CAN protocol uses a method called... I'll ask guiding questions along the way to help us understand this advanced automotive network. FlexRay is a high-speed, fault-tolerant communication bus designed specifically for demanding automotive applications. BMW was an early adopter, implementing it widely to manage the huge amounts of data required for complex, real-time control systems like the Integrated Chassis Management (ICM) and advanced safety features. Unlike the traditional CAN bus, FlexRay offers significantly higher bandwidth, up to 10 megabits per second, and, most importantly, deterministic communication. This means data is guaranteed to arrive within a specific, predictable time frame, which is absolutely crucial for systems requiring split-second synchronization and reliability. To begin our deep dive, we have a few paths we can take: architecture and protocol. We can dive into the technical details, like the communication cycle, frame structure, and how FlexRay achieves its time determinism and fault tolerance. FlexRay versus CAN. We can compare FlexRay's capabilities to the more common controller area network, CAN, bus to understand the limitations of CAN and why a new protocol was necessary for modern vehicles. Real-world BMW applications. We can look at the specific BMW systems that use FlexRay and why they need its speed and reliability, such as active steering and suspension components. Which of these areas seems most interesting to start with?
Alright, so let us look here. You finished calculate measure plan. Alright, that's it. So we have to go here and install BDC. We already did that, so we're going to click perform action plan. The token is already paid. So we're going to go ahead and click perform action plan. It should go ahead and repair the gateway. So we wait. Give it some time. It says right here, it said upon completion of programming coding, teach in the radio remote control by means of the operating instructions or the service information. Provided that the radio module for RS is active already, otherwise the radio module must first be activated with the service function. Activate the radio module. Alright, click OK. Okay, the BDC program and the ZGW program uncoded. So we look at it now. Here it's no more blue, there it goes. Green, green, green. All the way to that's good sign. So just want to keep up 67 fall codes, 67 fall codes, blah blah blah. Alright, the measure plan done now. Alright, so hold on, it's an action plan, install this, install that. Wicked. Ah, really? Bomba clock. Final report. Okay, flex ray is failing. Started at work. Alright, the motherfucking flex ray failed. Let me see the report. Lord clouds. I'll make sure it's that boy at the G12. Yeah, I see him, man. Alright, I'm going to take a look, you know. Alright. The case report. Alright, we have 73 fall code left. So the Z general program on the BDC all green and look sweet and nice. Boom, boom, boom. Alright, the fall code them now, I don't know. Let's see. The vehicle equipment page rejected. Bomba clot. If we get FS equal for this shit though. What the hell? Damn. Fuck, man. Ouch. I can't believe this shit, dude. Off the chain, baby. Off the chain. Yeah, I'll help with that. I'll help with that. Gee whiz. Ones work. Yeah, oh, this one, that's one of them on, this is exception here, the SAS, speed processing system. So if I can go like this and flexor is synchronized, I mean, I'm going to try to find this flexor synchronization. Jeez, man. Your fucking chicken. Your motherfucker. Special success. Alright, YouTubers, we're going to end the session right here. Brady C, already programmed the central gateway, which was in programming abort, is being restored. No big deal. I think Charlie take too long to respond. I can't deal with him right now. Alright, this module is not responding neither. This one or this one. This is the passenger seat, driver seat. These are probably seat belt reel. This one is speech processing and this one is for radar sensor. I'm going to close out the session. It's taking too long to answer. I can't wait on this shit, man. Every now and then we have to reset the ISTA page. And we gotta go here, downloads, get rid of this one. This is what we used to launch ISTA for the first time. We started from 118, so now it's for about 225. So when we close out the intersection, we have to delete that. So maybe the timing of that will be confused. So we have to get another one. Here's it right here. So we're gonna go back here and we're gonna unblock it. Usually when the file is downloaded from the internet, Windows have a feature that is block it, so you have to unblock it like that. Launch it again, open the software, let us see what's gonna play out. Oh man, another shit again. Alright, then we're gonna start the end of the video session and start one other video.